So what I'm going to talk about is how over the past 3 years, 2.5, 3 years, we've built our platform as a service product on AWS. So the company is Safe Software, that's who I work for, and the guys in the front. We're out in Surrey, there's about 120 of us, 110 of us. Probably one of the biggest software companies in Surrey actually. Not many people know who we are, but we do a lot of cool things, so I thought we'd share it tonight. And so I thought I'd kind of start with why are we presenting, you know, what have we done that makes us interesting, makes our scenario interesting, if you're looking from the outside. Firstly, I think we have a cutting-edge stack, taking advantage of the latest services. That's both on AWS and outside of AWS. We built AWS and Rails capability from nothing. People barely even knew what AWS was, including myself 3 years ago. Claude, our lead AWS guy, he didn't even know what it was either. And same with Rails as well. So that's kind of interesting. We worked as a startup within Safe Software. We were given complete autonomy thanks to Don. We used the services we want to use. We did what we wanted basically. And it worked well, it worked out in the end, I think, which is kind of interesting. So I think you can apply a lot of these things I talk about to kind of the startup model. And the product generates revenue and it's proven to be pretty stable. I think Claude maybe wouldn't say that, but I think it is. It has. We did it with a team of 3, plus me, I guess, so 4 of us. So what I'll do is just quickly go over what we do. I'm not trying to sell you anything here, I just want to give you context so you understand what the platform as a service does. Essentially we're a data integration company, so we integrate virtually any data, no coding required. So you can see we have a GUI here where you can design a workflow, so if you want to move data from Oracle to SQL Server, or from Dropbox to S3, you know, there's cloud and on-premises data formats. You can build these workflows and move data around. We do a little bit more than that. You know, there's a lot of companies out there that do kind of if this, then that, and people slinging data around. But our product's very powerful. It allows you to transform and manipulate the data. You can concatenate, you can rename, you can do basically whatever you want with it. You can filter. It's very, very powerful. We started out, and we really still predominantly in the geo industry, the GIS industry, so we work with the Esri and all the big GIS vendors, moving all of this geo data around, but we're starting to move out into just general data now. So yeah, you can connect to over 400 formats, and then we let you manipulate the data within the product, and then crucially the part we really do is the automation part. So you built a workflow that moves data out of Salesforce and loads it into SQL Azure and DynamoDB every day you want it to run. How do you make it run every day? And it's completely fault tolerant, it's going to work, it's going to run, it's going to do what you want. Or maybe you want to trigger a workflow from an incoming email or from a text message. So we basically automate the part of the workflow that you built. So yeah, we have 3 products: desktop, server, cloud. Desktop is the GUI. MapServer is the automation part, it's the enterprise piece of software. That's been going since 2009, I believe. And then really all FME Cloud is, I say really, is the FME server part running on AWS. So it's FME stands for Feature Manipulation Engine. So the company's been around for 20 years. It's kind of an old school acronym, but yeah, feature manipulation, good question. So what I'm going to do now is I'm just going to dive in and show you what the platform as a service product looks like. So the main thing to understand here is we didn't want to expose the end user to the complexity of AWS. You'll see that there is some ties to AWS here, but we wanted to really hide the complexities of AWS. So, let me just show you. So this is what the dashboard looks like. And we have a running instance here. So this instance is essentially an EC2 instance running out on Amazon that we've pre-configured with our software on it. But things go a little bit further than that. We monitor the software, so you can see in real time what's going on the server. We create backups automatically, and you can create snapshots from the backup if you want to persist the data after the instance is terminated. You can configure security and open up ports and close ports from the web GUI, and you can filter by IP. This is very important for our customers if they have an on-premises database. They want to connect it to the F&E cloud infrastructure, but they want to basically lock down, open a port but lock down the IP. And then we have alerts as well, so you can configure notifications if the server runs out of memory, runs out of CPU, is thrashing the CPU, runs out of disk or something like that. So that's the basic premise. If you want to launch an instance, it's as simple as going launch instance. You can choose a name, you can choose a URL. It's essentially building a URL up here that the instance will be located at. Click next. These are the builds of our product that you have access to. So this is this year, this is the beta, and then this is older builds. So this is important because all of these are being built automatically, and we'll show you how that works. But the new server build comes out every couple of days, and we aim to get that in the cloud within an hour once that's been built and it's being loaded and passed all the tests. So we'll choose to launch F&E Server 2015. And here, for those familiar more with Amazon, you'll start to realise the ties more. So you can choose the instance size, starter, standard, professional. So some customers are doing big bulk loads, and we need to scale across what we call engines. And it's really just about paralysing data integration tasks. And you can choose your region as well. We select this because we're a small team. We could just add all of the regions in there, fine, it's easy to do, but then we have to manage infrastructure across all of the regions. And we've got to always be cognizant of the fact there's only 3 of us. And so the number of F&E engines you can define as well, and you can also define the amount of disk space, but not just disk space. Now Amazon have changed things, so the more IOPS you want, the larger the disk space it is. So some clients will provision the largest disk just to get the performance. And then we also automatically patch the instance as well. So I click, that's it, I've configured my instance, and then I click launch. And now a whole bunch of things happen that I'm going to talk about over the next half an hour. And this is basically where a lot of the complexity is around this launch. And once the instance is running, you can also do a few things. You can force a backup, you can resize the disk, you can resize the instance type, so you can switch it from a starter to an enterprise on the fly. That takes about 30 seconds. So there's a lot of configuration you can do as well on each instance. Okay, so that's the last thing I'm going to really talk about, product. What we'll do now is dive into how this all works. So these are the services we're using to deliver the platform. This changes all the time. We encourage the guys to use a service that's the right fit at the right time. We recently just got rid of Scout, great service, but we switched to Liberato. It just fit our needs a little bit better. So these are not all of the services we're using on Amazon, but they're the main ones. And then again, even for management support, we're using services. So it's impossible to do what we've done without using services. Like the Braintree part, the credit card payments, that would have taken us as long to build as the platform that we're running. So I mean, you have to use services. Okay, so this is kind of an overview of our setup. So we've got the infrastructure account on the top, and this is where the Rails application is running. So this is what you just saw in the dashboard there. That's where this is powered from, this Rails stack. So in that infrastructure account, we have the automated build process, and then we have the instance actions. And then we have another account, and this is where all of the customers' instances live. So when I launch an instance there, this basically does the management of the command, the API call, and it passes that through, and then we provision capacity into this account. And that separation is very important because it means everything in here is just customer instances, and it's super locked down, IAM's highly configured, access is monitored, and then this is the infrastructure account where everything else kind of lives. So the first thing I want to talk about is the build process. So this is a relatively complex process actually. So picture this, every day, overnight, our test suite runs, I think it's on Amazon now actually, isn't it? We're nearly on Amazon. I think we're on Amazon. So every night, I think we have 40,000 tests or something that run, 10,000 tests that run. FME server passes, and the guys in the build team upload the FME server build to an S3 bucket for us. And they also post to an SMS topic to say, hey, new build for you guys. And the trouble is we don't trust their builds. I mean, they say it's passed in their stuff, but we don't trust them. So we have to do a lot of work to ensure that it's them working on the cloud. So we've got two workflows here. One is the FME server build coming in. That's one trigger point that can change, that can start a new build process. The other is Chef. So Chef is, we use it to configure and bootstrap the instance and run tests. And so if there's a new version of a Chef recipe, so let's say things the Chef recipe do is they set the host name when we launch the instance. What else do they do? Right, they put an SSL certificate there on the instance that's valid. They put the license there. So if this new version of that comes along, then we also need to trigger a build as well. So what happens is we have two SMS topics essentially that we hit, and then it goes into this AMI builder queue. And then we have an auto-scaling group set up on the AMI builder queue, and that basically, when something comes in, when there's a new build ready to start, this AMI builder instance launches, it pulls the queue for a new Chef server, and it starts doing a build. So what I mean by start doing a build is it takes a base the base EC2 instance, and it's going to install FME server on it, the software. It's going to then configure FME server, put the SSL certificate there, do a whole bunch of other things. Then it's going to run Chef mini test against the instance, because we've got to make sure that everything's running and it's all working on there. So we run a series of tests to test that everything's working. And then once everything's working, we send a topic to another AMI queue that basically tells a Rails worker to distribute between all of our regions and all of our different stage of production development environments. So this is potentially over-engineered. One might say that it's been a very good workflow for us, and it means without doing anything, we can respond to new builds coming in and build these AMIs up. Chef's been really great for us as well. You have to use Chef when you're trying to maintain and look after 50, 100, 200 cloud instances with all the versioning that you get there. The thing is this diagram is a little bit still out of date now. We feel we're starting to think about the future, and a lot of this pain we think can be taken away by Docker, container service, and Lambda. So if we go back to this diagram, the first thing that looks wrong to me now with Lambda being here are these two instances that we have. So AMI builder and Chef repo builder, all they really do is run code. They're coming online, they're responding to an event in the queue, and they're running code. So they've got to go. I mean, Lambda is Amazon's new compute service, and it essentially allows you to write code without worrying about any of the infrastructure. So we just write some code that looked in the queue, and then it could do a very, very similar thing. So that's the first thing that we could get rid of, potentially, is those instances. The next thing we could get rid of with Docker is we could push a lot of the configuration of the instance onto the build and release teams, and not our team. So I'm sure all of you know what Docker is, but Docker essentially, it's kind of the next step after server virtualization. So it allows you to really focus on, not on your infrastructure, but on your app. So you have a container, let's say we have with FME server in it, and then that container can be deployed on any platform, on any cloud platform actually, very, very easily. So Claude's the kind of expert on Docker if you want to talk to him later about it. He's spent a few months digging in deep. You can tell I haven't, so I'm not going to embarrass myself and try and tell you how I know everything about Docker, because I don't. But we are excited about it, but for us it's not quite there yet. I think you were saying, especially around the networking side of things, it's not quite where we need it to be, is it? And also we need the FME server product to catch up. We are going to have to basically re-engineer the FME server product to force it into the Docker model. But we're excited about Docker for several reasons. One is we're going to be able to launch instances. It takes about 7 minutes at the moment, 8 minutes on a bad day to 10 minutes. But that's going to be 10-15 seconds, so people are going to be able to bring instances up really quickly. Also, we're going to be able to run, you can basically run multiple containers on one EC2 instance. So you can optimize your infrastructure a lot more and reduce costs. And then all the technology around clustering and scaling as well. When someone wants to bulk load 1 billion records into DynamoDB, rather than having 10 jobs parallel, they could scale up for half an hour 10,000 jobs and bulk load in. So our software and the engine software is a great use case for Docker. So the next thing I'll talk about is the Rails stack, and this interface between the Rails stack and the API. This has caused us a world of pain. So this is when the user is in the web interface and they say, I want to start the instance. I want to resize the disk. So it's basically, in theory, it's just an API call. Just an API call to Amazon. The problem is Amazon doesn't work all the time. So we have to build a huge amount of fault tolerance into our code and into our logic to make sure that the customer gets a good experience. Because we don't want them just, if an API call fails, we need to retry. If an API call fails for 25 minutes, we need to tell the customer what's happening. And again, there's only a few of us, so we're automating as much as possible. So the Rails stack sits in Amazon as well. It used to sit on Engine Yard. That's a great company, but sign of the times we moved from Engine Yard over to OpsWorks. So it's a simple setup really. We have an elastic load balancer, we have our Rails instance running, and then we have these autoscale groups, is it? Set to 1, so if this disappears, another one comes up. We're not super worried about the 99.9999. This is good enough for us. If this fails, which it has done, I think maybe once in 3 years, this comes up in a couple of minutes. And then we have another instance with all the scheduling and where all the delayed jobs run, which are essentially workers. And then we use CloudFront. The CloudFront's great. We push all that. So in Rails, you compile assets like images and things, and CSS and JavaScript, and we push all those compiled assets to S3 and use CloudFront. This is really, really important for performance reasons. We have our customers all over the world, and you use CloudFront. It pushes those files to edge locations in Sydney, in Tokyo, in Frankfurt, so you get a much more performant web application. So what I want to talk through now is user disk resize. So you have an instance running and you want to resize the disk. And it sounds easy, there's an API call to do it, of course, in Amazon. It's not that easy to do, it turns out. So there's a bit of a backstory here. So these are all the steps it takes to resize a disk on Amazon. These are essentially all the stages, the API calls. You stop the instance, take a snapshot, you detach the UBS volume, you resize the UBS volume, you reattach UBS volume, and then on Linux you have to resize the partition. You have to tell Linux, hey, I've got a smaller or larger disk. So what we initially did is this was all in one step, basically. So we said, okay, this is what we need to do. It's kind of a logical grouping. We're going to stop the instance, and then resize it. And then the second step is we're going to go on the Linux machine and resize the partition. Quite a few problems arose with this. One is it blocked the worker for a long time, which is not good. That's not a good way to do things. You need to break things up into small pieces. But the problem is if the thing failed here, we didn't know it failed there. It just failed and something went wrong. So we couldn't tell the user what was happening. We didn't know how to respond. We didn't know whether to roll back, or we didn't know if the instance was damaged. So we had to get up in the night and have a look at it all. So that wasn't good. So what we needed to do is dramatically improve the process. And this is, I'm talking about disk resize here, but really I'm talking about any interaction with the Amazon API from a Rails application. You got a question?
So how do you copy? It's not meshing with the data, right? The data in the original case.
Right, so this is this disk that we're resizing. A customer might want to upload a whole bunch of their data themselves, so they might want to upload 10 terabytes of CSV files or something to that instance for processing, so they can resize their disk to get more size, and it's that disk we're letting them resize. Does that answer your question?
But the thing is, here you say create a new volume, not just.
Well, sorry, yeah, I think sorry, yeah, that's my bad. I think what we do is there's an API call to actually increase an EBS volume, isn't there? Okay.
The snapshot is volume snapshot, not instance snapshot, right?
Right. So yeah, sorry, yeah, we take a snapshot and then we're essentially resizing the snapshot. Okay. So what we essentially did is broke everything up into really small pieces so each bit could be retried. What we essentially did is we used a state machine to handle the transitions between stages. So if we look at this diagram here, this is the F&B Cloud dashboard. Initially, we're in the running state. The customer asks to reconfigure the disk. So what we do is that triggers an action in the state machine, and the state switches to reconfigure stopping. That state maps to a user state of stopping, logical for the end user. We then submit the job to a delayed job queue, which is just like a database queue that Rails uses to manage jobs, basically. So we submit the job to a queue that's essentially the API call to Amazon to do a pause request. So now the instance is pausing, it's pausing, it's pausing. The trouble is it didn't always pause. Sometimes the API call failed. Sometimes something went wrong with the pause state and it flipped back to running. So we make the API request and then we have another scheduler that polls the instance state every 15 seconds, I think, checking to see what the state is, what's the state, what the state. And if it's successful, it switches to the pause state. We send an action back to the state machine, to the pause action, and then that switches the state to reconfigure backup, and then this changes in the UI. So this goes on and on as well. We have basically a DJ queue and a scheduler for each state, and it varies slightly depending on what we're doing, but this was basically crucial to break things up into small pieces, and then in each of these entities, in the DJ queue and the scheduler, there's a few other things we do. So for failed requests, we retry using exponential backup. So this is, a lot of the time things will fail. It might not be down, something might not go right with the request. So we try using an exponential backup. That's kind of best practice that Amazon recommend. I think it's so, if the service is down and then it comes back, everyone doesn't hammer the service in the same second and take things down again. But I mean, it works well for us as well. And then the other thing we do is we have secondary jobs to watch over critical steps. So here, I'll just talk you through an example. So this is Amazon's instant lifecycle management drawing. So if you have an instance running in stop state, and you move, so what would it be? It would be if it's stopped and you start it. So if it's stopped and you switch an instance to start to try and unpause the instance, and basically it switches to its pending state. So this diagram would suggest it can go from stop to pending, but never from pending to stopped. The trouble is it did go from pending to stopped. And we saw it happen, we contacted Amazon and they said, yeah, it can happen, you guard for it. So we thought, okay, what we'll do is, when we submit the request to start the instance, to get the instance running, we'll set another job in 2 minutes to check that it is running. So you need to think about that logic. You know, if you're doing a really important task and you've got no way of knowing when the instance is running or when it isn't running, you know, have other workers that run. Okay, so yeah, that's basically this resize logic. The next thing I want to talk about is the launch process. So again, this is another huge point of failure. We have a lot of kernel failures with instances. API requests failing that cause the stack to fail. And so, remember, we have our base AMI that we've created from the build process. So that's sat there ready to go. And then a customer says, okay, I want to launch an instance based on this base AMI. So what we do is we use the Ruby SDK is essentially just the Rails tier, the web application, and we create a CloudFormation template. So we take a CloudFormation JSON file and then we inject user-specific attributes into that template. So what size disk do they want? What instance type do they want? That all basically gets configured and we create a nice JSON file, a CloudFormation template. The CloudFormation template is great when using AMIs because what it does is it basically configures all of your resources for you. So it launches the AMI, but it also creates an IAM role, it also creates an instance queue, it also adds a DNS entry, and it does all of these things and it checks that it's done them. And then if anything ever goes wrong, it automatically rolls everything back, destroys everything, cleans up after itself, and then you can try again. So it's a really clean way of launching a stack. So what happens is we launch this stack, we bring all the pieces up, and then so this is what the CloudFormation, this is part of what the JSON looks like. So you can see we're installing Python libraries, we're installing Ruby gems that we need. You can ask Paul what that does, I'm not sure what that does. So, but you can add elements to the JSON file and basically configure the instance. But then once the instance is running, we still need to make sure that it's properly working. So we use Chef mini tests. We pull Chef scripts down from an S3 bucket, and we run these Chef mini tests. So to say, can we download a file? Just some basic tests to make sure the server's as expected. And at this point, if things do go wrong, we can still send a failure message to CloudFormation, because it has an API, and we can say, kill it, fail, it's gone wrong, try again, something's not working. So again, this is a key piece actually, this mini test, to make sure everything's as expected, because to start with we didn't have it and everything looked good, it came up, and then there was an internal piece of the application that wasn't working as expected. The email server wasn't up, the WebSocket server wasn't up. So that's kind of the launch part of things. So yeah, so key points in the launch process. We tried 3 CloudFormation launches, and if they all fail, we give up basically, and we tell the user, sorry, the instance launch failed, and we get PagerDuty errors to say something's gone badly wrong with the stack. And then we bootstrap the instance as well. And so in the CloudFormation template, you can use metadata to essentially inject bash code. So this bash code will run on instance launch, and we pull down the Chef recipes, and we do pull down license and do various things when that bash code runs. So you have to separate what you do in the builder, in that initial process to build the AMI, and what we do in here. And you need to make this as small as possible, this part, because you need to be fast. So you don't want to be configuring things and installing things in this part, because that takes time. So we try and keep this as lean as possible to get the launch time as low as possible. Okay, so the next part I want to discuss was the billing workflow. So billing, everyone's worst nightmare basically. Taking money off people is hard, so what we do is people can pay per hour, so they can launch a cloud instance and they pay per hour just with Amazon, so essentially marking up Amazon. So what we do is, I don't know if you know, but Amazon essentially has this cost allocation spreadsheet that it puts in an S3 bucket for you. And this cost allocation spreadsheet has all of the all of the AWS services that you're using, and it has basically cost value against them to say how much you've been using them, how much volume, how much price. And it updates these every hour, is it? About? We don't really know. Oh, every 6 hours, okay. So basically what we do is every 6 hours we import this cost allocation spreadsheet, we update our instance cost table, and then we present that to the end user in the GUI. So you can go into your GUI in here, this might be useful for you actually. And you can actually go and see your current monthly usage. We essentially rely on pulling that cost allocation and calculating the billing for the customer. And that's to give them confidence, because we found out early on people were panicking. What's the end of the month bill going to look like? They didn't trust the pricing, so we put this in so they can check. And it definitely eased them into the product line. So that's what we do in basically every 6 hours that process runs. And then at the end of the month, we get a little bit more complicated. So we pull the monthly cost allocation report in, we pull how many credits they have, because we have credit models so they can purchase credits. And then we generate invoices, so we send out PDF invoices to the client by email, and then using Braintree we charge their credit card. So it's a nice workflow. It's quite complicated, isn't it? But it works, and it gives a really nice experience for the end user, because they're getting real-time billing basically. But there's definitely some gotchas. Invoicing and charging people is a real pain. So make the technology as simple as you can. Like, you don't want to be worried about technology when you're billing people, because people want refunds, their credit card's declining, you've got to look up, credit card decline codes and talk to the client and say your card's expired or someone stole your card, you need to update. So get rid of the technology as much as you can. Things changed in the cost allocation report that was burned to us. We thought it was a static thing that was like, never changed, but I think, what was it? Was it some kind of...
It was a recording called Record ID, which was it actually showed us every time you shoot it, or that record shift. So if you phase it, that's a uniqueness of that recording.
Right. Yeah, so, there's a few things. The other thing is, for us, again, a small team, as soon as you start moving into AWS region, pricing gets complicated, because we buy reserved instances to lower our costs, and reserved instances are not only by region, but they're also by AZ. So if you manage 100 instances, you've got to somehow work out how to get the right reserved instances, and we use Cloudability to do that, which is a service that recommends which RIs you should buy, because it's basically impossible to do. And Amazon have this thing called Trusted Advisor, but it's expensive. I think it's 20% of your cost on Amazon. So Cloudability is a cheaper way to do it. Okay, so that's kind of the interface between the Rails tier and the EC2 instances and how we provision and launch. The next thing I just want to talk about is instance management. So how we're monitoring the instance, how we communicate with the instance, and how we're securing the instance as well. So monitoring is relatively simple. There's an open source tool called CollectD that we run on the instance, and that basically pumps a whole bunch of data from the instance to Liberato. And Liberato is a service that takes all that raw data from CollectD and basically turns it into API endpoints that you can access and nice graphs and charts and dashboards. So the monitoring is quite easy to do actually, but it's not. There's a lot of complexity around the notification side of things, because we built a notification framework on top of Liberato that says if the disk is only got 5 gigabytes left, send an email to the user. Because at the moment, if an instance runs out of disk space, it's our problem, because the customer doesn't know about it, so we're not notifying them. And again, if a customer runs out of disk space, it's not really our problem. They can fix it themselves, so we prefer to tell them. The next thing is instance communication. So we made a conscious decision early on to essentially not allow customers to SSH onto their instance. They could only access the instance through the API, the FBServer API, or through the FBServer web UI. Very good decision actually, because if you let customers onto a Linux instance with permissions, they could just cause all sorts of pain, and then we wouldn't want to manage it. So we basically said, you're not allowed to SSH in the instance, but then we worked out we needed to perform certain tasks that could only be done on the instance. We needed to trigger a snapshot from the instance. The reason is because you have to pause the disk before you trigger a snapshot. So other things, update, patch the operating system, licensing. So essentially how we do it is when the CloudFormation launches, it creates a queue for every instance, this instance incoming queue. And so what we would do is we send a message into the instance incoming queue, and then we have a Ruby script that's scheduled that runs every hour, let's say, and it pulls down. It's basically, it pulls down the script from the queue, and then it runs the script on the instance. And then when it's done, it puts a message back in the outgoing queue that the Rails tier can pick up and proceed. So that's worked really well for us actually. We had up on Sunday when SNS and SQS went away for, 6 hours or something? It was before. And then there was one in August as well, right? So we kind of assumed that SQS was never going to fail. That was a bad assumption, yeah, it does fail. So you have to code for that. Actually, you have to code for it. Assume everything's going to break. That's what we've learned. Don't assume anything's going to work, because it probably will break, at least when you want it to. Security, so this is a big deal, and it's misunderstood to an extent by clients. So, they come to us and they say, okay, how many nines is your stack? And they're like, we run Amazon, we're quite stable, so well, I need 7 nines. You're like, well, I'm not sure the planet has, 7 nines of failover, so I don't think we can guarantee that. But they don't fully understand it. So what we've kind of done is an education program for our clients. So we've created white papers around what we're doing and provide transparency around the stack and what we're doing. And also Amazon has a huge amount of material. So look at your cloud provider if you need to appease anyone's concerns and provide their documentation. It's very extensive, and when you start saying that their data centers are basically fortresses that people can't get into compared to their own data centers, then you start to think, oh, okay, well maybe it is a little bit more secure than my server running under my desk. And the other thing is, we needed to find a security company to partner with. This worked really well for us. We worked with a firm down in San Francisco, and he did penetration testing, vulnerability testing against the stack. He advised on security first design and got us thinking in the right way. I'd really recommend doing that early on, because these guys, they can't grab all of the certifications you need and all the training. The other thing is look at network security services. So we use Qualys. It runs against the stack the whole time, checking for vulnerabilities. Okay, so yeah, that's kind of an overview of all the different things that we're doing roughly with Amazon. Just to end with a few key takeaways. So we kind of say design for 99.9. So assume everything's going to be not working for 45 minutes, an hour every month. You're not, SQS is going to break basically. That's a good thing to aim for. Yeah, design could embrace change. Don't be scared to throw code away. Don't be scared to throw services away if it matches what you need going forward. We try to stay up to date and use things that work for us. And the thing is with services, the first thing I look at when I go to a service isn't all of the fancy marketing stuff. I go straight to the API and I say, okay, can I get everything out of this service easily? Is the API well docked? Is the API, does it look good? Is it usable? Because if I can get everything out of the service, then the risk is relatively low to have a go using it. You have to manage coding new features for coding stability, or ops will destroy you. There can be several months go by where the customer doesn't see any new feature because these guys are refactoring. They're basically making the code more stable, or adding state machine there. There's just refactoring everything based on the lessons that we've learned. So every time there's a failure on Amazon that we get woken up by on PagerDuty, we basically try and code and fix that. It's not 100% possible, but otherwise every month we lose a few percent of our productivity to ops. Obviously it can't go forever, but that's the aim. Yeah, keep your costs in check, start small, and you can design to scale when you need. You know, Amazon's perfect for that, like the cloud is, and most of the services are as well. But yeah, you don't need to really worry about scale until you need to scale, because scaling is pretty easy now. Just go talk to Joe and he'll help you out. Other points, yeah, services dramatically reduce your code base and maintenance cycles. You know, they push things to the company as well. It's not just code, like Braintree are PCI compliant, so we don't have to worry about storing credit cards, we never see them, they're PCI compliant, we don't have to deal with it. Launch as soon as you have a viable product and heavily support early customers. So we launched pretty early. Amazon are quite good at doing this too. They launch throw products out there, they get people using it, they get feedback. We had a couple of really good early clients who wanted to move, they had no other option. It was cloud or it was nothing. So we helped them, we coded for them, we made features happen for them, we learned from them. And that was really important for us. This is another one, get live chatting there as soon as possible. You need to lower the barriers to the customer as low as possible. You need to talk to all of them. Really, when they're coming in these early cycles, you need to try and understand what all of them are doing. Think outside the box for recruiting as well. It's very hard to hire Rails, AWS developers. You know, Claude's from Switzerland with geomatics degree, he came on a term, we pulled him over. Arash came through Code Core. He learned Rails through there, now he's kind of like the lead Rails guy, so you know, Code Core is great for him as well. But yeah, you need to think outside the box. And the thing is, things are moving so quickly, I don't even really look for like, oh, I want them to have AWS as well, because in 6 months it's all different anyway. So it's their ability to learn and their willingness to learn as well that we look for. Yeah, we're hiring as well, so this is the team, we're out in Surrey. Yeah, that was a presentation. There's 4 all here, probably for a good while afterwards, so come and talk to us. I'd probably do a lot at you there. If anyone has any questions, yeah, sure.
So a few slides ago, you talked about Rails applications to SQS. I noticed that there's an SNS layer as well.
Yeah.
I can guess what this is for, but could you elaborate on why is it?
So I'll try and answer this in Claude. So you kind of mean, well, here there's an SNS layer between SQS and Rails. Yeah, so go on, Claude.
First on it's for flexibility. So not in the side of the instance, but on the other side you can replace the queue with webhook if you need to, if you need more performance. And second, I thought SNS is more stable than SQS. I couldn't have been more wrong, but well, that was a decision we took very early on, and it's there. It works really well, but yeah.
It gives you another layer of
Yeah, I think it's good because you can do things like send an email, or it makes your system, your architecture more flexible. So yeah, we generally put SMS everywhere. Any other questions?
So your service is to all people transfer data from relation database to some.
Yeah.
So the question is, how large of the data does your platform can perform?
So this is the thing. So often what we're doing is moving data from point A to point B. So we're not actually caching or storing the data in large volume on the instance. We're kind of like a pipe. So everything flows through our instance, and we do the transformation, and then we write the data out. So, you know, some jobs take 5 seconds, and then some jobs take 3 weeks, pumping huge volumes of data. It really depends on the use case of the individual. But we're more like a pipe. We don't have to pull the entire thing down to do the transformation.
And it says to someone that users have.
The what's it? The instant
Users have.
instance tab or type. We ran benchmarking tests against all the different EC2 instances. Both the kind of test framework, and we had performance tests running based on about 5 scenarios. And that's how we came with our pricing. So this instance was about twice as fast as the smaller one, so we're going to make the pricing a little bit less than double. It was a lot of work to do that, actually. Yeah.
From your experience, if you had a wish list for AWS, what would it have?
Good question. Okay, so that was reliable support. So actually, that's a fair point. So we actually do find it very difficult to interact with the company. It's kind of a big black box. It's hard for us. We have a sales guy. I've emailed him lots. He never talks to us really. I think John has a bit more success, but yeah, I mean, if we submit a support case, we're on a certain tier pricing, and we're meant to get, is it 4-hour response or something. I mean, you know, we've got 4 or 5 days. That's you know, so I know you guys get busy, but that's probably one thing for me. Anything else? Wish list. It is an amazing platform. It's just we're like almost blown away when you come out with new things, and it's ever evolving. So I mean, I can't really think to outthink you guys, but it's yeah, that was probably one of my biggest ones. Any other questions?
Yeah, how do you access the actual software then? Like the application, means the application is all around the server components.
Right. So the FME server running on the instance is accessed via an REST API or a web app.
And where does that run?
That runs, what's that? It's Tomcat. We use Java servlets running on the server. We use Tomcat running. We use servlets basically to power the services. They're all just running on the instance, so it's a single tenant, one instance, one install of server. Yeah.
You mentioned you're running the FME server in 3 regions, and you allow the customer to push the AWS through CEM. And you mentioned the top queue as one of the targets as 3 regions.
Yeah.
So did you cancel the data transfer from different regions to the only region that you are running the FME server?
Yeah, that's a good question. So basically, it just changed this recently. Actually, what we do for fees on Amazon, because you're right. So what we essentially do is, let's say the smallest instance is $1 an hour. So essentially, marking up leases to costs. But if someone pumps 20 terabytes of data through that instance in a month, we could get a $2,000 bill. So we basically pass through. We take the line items from the cost allocation spreadsheet and pass those costs directly through to the end user, and we do charge them for the AWS costs. I think we used to mark it up, but we don't anymore. We just pass the costs on.
Maybe more of a business question. Do you cap those costs at some point, or do you have to worry about like clients doing the wrong thing and?
Yeah, so we have a trial program where they basically they sign up and they have to put the credit card in, and seemingly don't read everything because they put the credit card in, they get $250 credit to play, but then when that runs out, they basically it starts charging the credit card. So we're going to have to stop that because a lot of people use it, they leave it running, they forget, and then the credits run out. We email them again. And they still leave it running, and then they get a bill on a credit card. But in terms of costs from our clients, like our bigger clients using it, generally we've had a conversation with them. We have a relationship with them, a certain account managers assigned to them, so they generally know the deal before they start pumping huge volumes of data through. Yeah.
The logic to resize this development.
Yeah.
So we mentioned the challenge, like you have multiple steps, some of the steps may fail and you don't know. Like it's hard to trace which step failed. So have you ever considered using Amazon support? Like it's designed to handle the resize steps, data management, or
Okay.
it's probably one concern.
Okay, thank you. Maybe we'll look into that at the conference. And we have, I think Claude's looked at it, you have mentioned it before, haven't you? But it's kind of yeah. Okay, thank you. Any other questions? You've been great questions so far.
On the, it's something you did from source,
Yeah.
translating and whatnot, looking into an endpoint. How much through the firewall on the other side? Sort of,
Right, so basically each instance has its own security group essentially on Amazon. So in the web browser we let the person open up specific ports on the instance. So let's say we have one client in England and he has a database running on premises. He's open port, let's say 5462. To the outside world he has done that, but he's tied it to the IP of the instance out there. And we do the reverse. He opens it on the cloud instance and he ties it to his internal IP. And we're actually just as interested in playing because many clients have been burned because the problem what happens is they're tying it to the IP of the instance, but when you pause the instance and start it again, you get a new IP. So we have a convoluted workflow where you could get the IP from the API and they're using all that, but what we're essentially doing this week is we're going to be adding Elastic IP support into the product, so you'll be able to assign the instance to an Elastic IP. We were a little bit worried about that because there's a limit to how many Elastic IPs Amazon give out, but they reassured us that if we need them, we will get them. So,
Are you running it all in one VPC, or what does that look like?
do we have a VPC per?
Yeah, we run, so we run all the custom instances in one VPC, and we have like subnets just randomly distributed between ACs, so that if one AC goes down, at least not all customers are offline.
Yeah, as good as we've got at the moment. We don't, that's a good point, we don't really have fault tolerance at the moment, so you launch an instance in a certain region and data center, if it goes down then that's just too bad at the moment. So using Docker, hopefully eventually we'll be able to deploy multi-region and multi-AZ if the customer requests it. Any other questions? Thanks for listening. I know there was a lot in there, so I hope it's